In this lesson, we will focus on wide area networks and we will learn WAN topology types. Let's see that if you can answer 5 questions at the end of this lesson correctly, good luck. As we have mentioned in the previous lessons, wide area networks are the largest network types. If you would like to learn more about other network types, you can check also the related lesson. We connect networks over long distances like cities, countries, and continentals with WAN links. Here, we will focus on 5 WAN topologies. Then what are these WAN topology types? Let's learn one by one. The first WAN topology types is point-to-point topology. This is the simplest WAN topology type. A point-to-point connection connect one site to other site as they are directly connected. This WAN connection type is an expensive solution because you are giving a private link to this one connection. Leased lines are a good example for the point-to-point WAN topology. The second topology type is hub and spoke topology. In this topology type, there are 2 different roles as its name implies. One is hub and the other is spoke. Central device that is connected to other devices is called hub, and the other devices that central node is connected are called spokes. Hub and spoke topology is also an expensive solution because it needs a point-to-point private connection for each site. There is also a less expensive version which is done as point-to-multipoint topology. This is also a hub and spoke topology. Here, the disadvantage is there is only one central hub and it is the single point of failure. This means that if there is a failure in the hub, network has a big problem. Third WAN topology is full mesh topology. In full mesh topology, all the nodes are connected to other nodes. Because of this redundant links, this topology is the most redundant WAN topology. But because of this, it is expensive. How many links do we need for a full mesh WAN topology? To calculate this, we have a formula. N times N minus 1 divided by 2. N is the number of the devices in the topology. For example, on the screen, we have a full mesh WAN topology. Here, we have 4 devices that connect each other. So for this topology, N is 4. 4 times open parenthesis, 4 minus 1, close parenthesis, divided by 2 equals 6. We have 6 connections. Another WAN topology is dual-homed topology. In this WAN topology, sites are connected to other 2 sites for redundancy and load balancing. There are 2 links to 2 different sites. This mechanism provides more secure, redundant network. It also allows load balancing for better network performance. Some of the traffic prefers going through one link and some of them prefers another link. Service provider networks use this topology to provide redundancy on their service links. If you need more redundancy, security, and load balancing, then here is the 5th WAN topology, dual multi-home topology. Here there are 4 links towards 2 different sites. This topology provides more redundancy, more security, and more performance because even if one of these links fails, the other links can handle the total traffic of the network. So service provider networks use this topology also. This is the end of our lesson. Now let's see that if you can answer these 5 questions correctly. Which WAN topology is like leased lines? Point-to-point, hub and spoke, full mesh, dual-homed, all of them. The answer is A, point-to-point. In which WAN topology there is a central node which connects to other sites? Point-to-point, hub and spoke, full mesh, dual-homed, all of them. The answer is hub and spoke topology. In which WAN topology all nodes are connected to the other nodes? Point-to-point, hub and spoke, full mesh, dual-homed, all of them. The answer is full mesh topology. How many connections are needed for a full mesh topology with 10 nodes? 10, 25, 30, 45, or 90? The answer is 45. 10 times 10 minus 1 divided by 2 equals 45. How many connections are needed for dual homed connection from a site to the other end? 1, 2, 4, 8, or 10? The answer is 2 connections. Yes, it is over. If you like this video, please like, share, and subscribe. Good luck!